Hey, good afternoon, Luke. How are you doing?
Hey, Tim. I'm doing good. Actually,
All
but
right.
well, we're in the same time zone, so it is afternoon, evening.
Right, yeah, we are. But we have people from all over the world, I guess. So is everything set up for today's masterclass? You ready?
Yes, we are all good to go. I'm excited for this session. I always appreciate it a little bit more when it's something that I've actually dealt with, like from personal experience. So I've been part of a team that had to work on a solution like this. So that, that definitely helps me resonate a lot more.
Can't wait to hear about it. All right, let's kick things off. Good morning, good afternoon, good evening, everybody. Welcome to today's masterclass. My name is Tim Janich. I'm the Director of Community Evangelism here in the SUSE and Rancher community. I will be facilitating today's session. And before we dive into the subject matter, I would like to really briefly acquaint you with our platform, our webinar platform, which is Crowdcast. Luke, if you could show the Crowdcast slide, please.
Absolutely.
There we go. So first and foremost, this session, like all the other sessions that we're doing, is going to be is recorded. We are going to, the recording is going to be available here in Crowdcast. For those of you who have attended a session like this before, you already know that. But we will also share it on YouTube and let you know in our community site when the recording is available. If you don't know where to find our community site, you find that little green button at the bottom of your screen, which says join the SUSE and Rancher community. That's what takes you to where you will get the notification when the recording becomes available. You can ask us questions at any point in time. There is a little ask a question button at the bottom of your screen. You would do us a great favor if you would put your questions in there. You can totally talk to us in the chat as well. But if you have a question that you want us to specifically pick up during our Q&A part, that's where things become a little bit easier for us if you put them into the Ask a Questions menu. We will have polls as well. That's right next to the Ask a Question. We already have one live. There are a few more coming in the remainder of the session. And as I said already, you can talk to us in chat. You can talk to your fellow participants in chat and let us know, for example, where you are. Say hi to everybody, what you think about the session. If you have a comment on something, we will have a look every now and then, and we'll try to interact with you that way as well. All right, now that the formalities are out of the way, let's dive into technology. But first and foremost, I would like to introduce our expert, Luke. Luke, who are you?
Just the guy in Africa. No, kidding. So my name is Lukonde Mwila, or you can call me Luke. As I've said several times, you can get away with calling me Skywalker because I'm a Star Wars fan. Bear in mind, Tim is not the biggest Star Wars fan, so he will not be calling me Skywalker. And I'm a senior technical evangelist at SUSE, part of the SUSE and Rancher community team.
Awesome. And today's masterclass is the second in our series, Cloud Native at Scale. Can you briefly remind us what that is about and what you did in last week's session, which was the first one out of this series?
Yep, absolutely. So essentially, we recognize the fact that the cloud native landscape is increasing in popularity. The growth trajectory is quite clear that there's a high adoption rate. And so what we're essentially doing with this series is trying to equip people or help developers, operators, solution architects, wherever you fit in. But as long as you're a part of the cloud native community or space, you want to be able to not just understand things at a basic or fundamental level or work with things at what might be considered more of a proof of concept. There are a lot of people trying to solve some real problems at a much larger scale. And so we recognize that. And as a team, we're essentially trying to help fill that gap by covering different dimensions that would address the main areas when it comes to scaling in the cloud native space. So we're doing that in 4 different dimensions. And those 4 dimensions are the ones that are presented on the slide that you can see over there: cluster management at scale, applications at scale, utilization at scale, and deployments at scale. Now, each of those 4 dimensions have different topics that we'll be covering. So we are still in part 1 of the series, or the journey, if you want to call it that. We are still in the cloud, in the cluster management at scale. And last week, we were looking at using Rancher to manage multiple Kubernetes clusters, specifically hosted clusters like AKS, GKE, and EKS, because Rancher does allow you to manage those completely in terms of their life cycle. But also we recognize the fact that those are 3 popular hosted clusters that a lot of teams are making use of. And so we wanted to show how you can essentially have a single pane of glass to manage each of those different clusters. Whether you have you're making use of a multi-cloud model, and so you're actually making use of each of those respective clusters depending on your use case, or maybe it's that you're using multiple GKE clusters, whatever the case may be. What we were essentially trying to demonstrate how there's some serious problems that come into play when you're managing multiple Kubernetes clusters. Things get complex and tricky. Also, when in the areas of teams and the areas of security. And so what we were essentially trying to do is help you pinpoint what those problems are and how you can solve those problems making use of a platform like Rancher. And so today's session carries on from that, and there will be a little bit of overlap just because today also covers managing multiple clusters, but we're trying to look at the different dynamics, specifically when it comes to scaling the number of tenants that are dealing with the underlying Kubernetes clusters. So we'll be focusing on that today. And yeah, like I said earlier, I'm excited to cover this because it's something that I've personally dealt with as when I was part of a team. And so I'm hopeful that the principles and the techniques that we'll essentially be trying to get across will be very useful to those who are tuning into the session.
All right. So I think you have a little bit more information on what exactly we're going to cover in today's session, right? Do you want to talk us through that before we dive right in?
Yep, absolutely. So just going back to the whole idea of doing Kubernetes or cloud native at scale, what you find in a number of organizations is there could be multiple tenants, and tenants could be applications, it could be teams, it could be customers, that are essentially accessing the same Kubernetes cluster. And this is very popular even in a multi-cluster model. So we were talking a lot about managing multiple clusters last week, and we also showed how there are different models. And one of the models that we showed was one in which you could have a single cluster out of those multiple ones in which you have multiple teams accessing that cluster because there are different applications running there, or it could be that they are accessing different namespaces or different environments. Now, the reality is this becomes very tricky because tenants shouldn't necessarily have any kind of interaction within the cluster, so they can share the space, but how do you create the right kind of isolation and security and make sure that you're also managing your resources in an optimal way as things are scaling? And those are some of the problems that do rise up in the journey. And so today we're going to be looking at the issues that can go wrong if you don't address these kinds of things, but more importantly, the solutions that you can implement when it comes to multi-tenancy and the 2 main paradigms that exist in that space as well. Great. So here's what we have lined up for today. We're going to be talking first about multi-tenancy in Kubernetes. As usual, it's good to lay the foundation, understand what the core issue is, and before we jump straight to solutions. So let's talk about this actual thing that we identify as a potential problem. And you'll see industry at large is continuously trying to help address these particular things, because Kubernetes being a robust platform that can host multiple applications or multiple tenants is essentially in and of itself is a solution or platform that invites people to adopt it or make use of it in that particular way. But you want to make sure you're doing it the right way, and you want to make sure that you identify what can go wrong and make sure you understand what the best practices are. And we want to help with that particular journey today. So it all starts with making sure you understand what multi-tenancy actually is in the context of Kubernetes. And then we'll dive deeper into the different paradigms or solutions that you can essentially make use of to make sure that you're doing multi-tenancy in the best way possible. So that will be cluster personas, namespaces, RBAC, network policies, and resource quotas. And then right at the end, we'll have some time dedicated for Q&A. And like Tim said earlier, please note that you can ask your questions in the Ask a Question section in the bottom right corner of Crowdcast. And you might find that even during the course of this particular class, Tim might just interject and go ahead and shoot a direct question my way, and that'll be totally fine. So please, I hope you have lots of questions. Again, this is an exciting topic. It's an important topic. And we want to be able to make sure that we're imparting the right kind of information and that you can make use of it in your context. I had a look at the poll, and I did see that there are a couple of people who are making use of it already. So it would be great to hear, to see some questions coming through also that maybe if you're seeing something that differs from your particular context or the way you're doing things, or what you see proposed today that could be applied in your scenario. And I see there are also most of the people actually aren't making use of multi-tenancy, but they are interested in learning this. So I am keen to get going. All right, so for starters, what is multi-tenancy in Kubernetes? Right, so multi-tenancy in Kubernetes is a cluster model or paradigm that essentially in which you have a single Kubernetes cluster that hosts or is shared by multiple tenants. And like I said earlier, don't get confused by tenants, because that essentially can apply to multiple different scenarios. It could be teams, it could be applications, it could be customers, or it could be projects at large. And an analogy that I really like when it comes to multi-tenancy in the context of Kubernetes is that of an apartment building, right? So the opposite of multi-tenancy would be single tenancy, in which that would look a lot like a single house, right? And so you're not worried too much about having strict isolation, privacy, or resource sharing when you think of it in the context of a single house. But in an apartment building, you definitely are. You have multiple tenants, which is what we're essentially conveying over here. And with those multiple tenants, you don't want a situation where one tenant in an apartment building turns on the lights and that results in the lights going off for another tenant, or turning on the shower for one tenant means no water is available for another tenant. And in addition to that, you want tenants to have the right level of privacy and isolation with regards or with respect to their rooms in the context of an apartment building. And that translates to the context of Kubernetes in the exact same way. And this will look different depending on who your tenants are or what your tenants are. And you'll see that as we go along. But very important to note over here is the Kubernetes cluster is essentially being shared by these different tenants. So resources like CPU, memory, networking, and the control plane are essentially being accessed by these different tenants over here. And so you might have already started picking up on what challenges that can introduce. I already alluded to some of them with that analogy. And I'll use the example over here with the context of two separate software development teams. So you could have an organization that has deployed applications that are running side by side, but those applications each have their own resource demands. And I have a diagram coming up that I can't wait for you to see. I was excited about putting this one together, so I really hope you like it. But essentially, when you have these applications running side by side, they're essentially going to be competing for resources as they scale. And that I hope you see that thread that fits right back into what we're trying to deal with over here at large with cloud native at scale. And we recognize that. And this diagram over here may just be depicting, two sets of tenant developers, but in reality, with large organizations, you have several different software teams that are each working on multiple applications that could be running different backends, running front-end applications or a host of different microservices, and they need to be able to manage that the right way. And bear in mind that these Kubernetes clusters that are being shared by multiple tenants, this can still fit within the model of a multi-cluster model, What it simply means is that a single cluster within that multi-cluster model is being shared by multiple tenants. So I certainly hope that that doesn't cause any confusion. All right, and on the right there, we have the diagram that I was referring to, which I certainly hope you're gonna like. But the point of this is actually just to help depict what happens if you don't set any restrictions on your containers. And what happens is, if you can see over there, that this diagram is basically a Pac-Man grid. And so we've got little Docker logos over there that are representing your containers. And what I'm trying to depict over here is the fact that when you have, when containers have untethered access to resources, they'll basically make the most of what they have available to them in order for them to function as expected. So I was saying, you don't want to end up in a situation where you have your containers basically being Pac-Man in a grid on your nodes. That could lead to some very serious problems. Examples are demonstrated over there on the left-hand side. This could lead to node constraints or starvation. And a dirty approach to this would basically be, oh, I'm going to increase my node count. And that's not exactly optimal, because that's going to definitely increase your costs. And more than that, you're actually missing out on the opportunity to understand what your containers actually require in terms of CPU and memory. So it's best to actually set thresholds for them, set a limit on each one of them, and metrics come in handy over here as well, as you get that continuous insight and visibility over time, and you can optimize usage of your nodes as well. Another thing that is very tricky when it comes to cluster management is finding the right size node. And so if you're just going to follow an approach where you're just increasing the number of nodes, you're making you're going to essentially end up in a terrible pit. What you want to do is make sure that you're optimizing at every level, starting from the containers. And then when it comes to your nodes and you have those limits set, you can actually start to see, actually, I need to change my node type and optimize it either for CPU or memory based on what my workload is. In addition to that, and this one might be a bit of a no-brainer, due to the congestion, you're going to start to have performance issues. So again, just referring to that Pac-Man grid on the right over there, as your containers are scaling and making the most of resources, the less that there will actually be available, and you're going to start to have downgraded performance as your traffic increases for your particular workload. And not only that, like I said, in the enterprise context, a lot of organizations are actually making use of several tenants for their Kubernetes clusters, and it becomes very difficult to plan for additional applications and growth in that regard, because the applications or the tenants that you already have that are making use of those underlying clusters that you have at that point in time, are not optimized. And so you're already constrained, and it becomes difficult to plan even for the future. Not only that, you could start to have some issues between teams that are deploying these applications, because essentially what their workloads are now contesting for the resources on the nodes that are being used by the Kubernetes cluster. Let me boil it down to these two models or paradigms that solve this issue for us, and you might have picked up on it already. I think I did allude to it. It comes down to resource sharing and security, right? And so with resource sharing, you want to make sure each tenant has what they need in order for them to function properly. And from security, you want to ensure that there is sufficient isolation between the tenants. And so I'm going to expand on the ways in which you can essentially apply these two items, which are like the umbrellas of the underlying solutions that we'll be covering. But before we get to that, I want to mention as well that within multi-tenancy, you have two different models that you can take on. There is soft multi-tenancy and there is hard multi-tenancy. And so soft multi-tenancy is suitable for trusted tenants. And so you'll find that in these kinds of scenarios, there might not be strict isolation between the tenants. A good example of this would be an organization that has a DevOps or IT ops team and application developers. You heard me mention earlier that I have a little bit of experience in, with following this particular model. And this is the one that I was actually in, part of an ops team. And there were also there were application developers and there were testers that needed to have access to the Kubernetes cluster. And so in this kind of scenario, you would be looking at following a soft multi-tenancy approach, because you are dealing with trusted people. Your ops teams are probably even going to be interacting a lot with the application developers. And so you just want to make sure that there's enough isolation or enough resource sharing for the workloads that are being deployed as it pertains to their respective items. When it comes to hard multi-tenancy, this enforces a much stricter isolation to prevent any kind of negative impact on other tenants on the cluster. You essentially assume that any tenant is capable of malicious behavior. So this could be common where you have customers that are accessing the cluster, or if you have shared infrastructure across organizations, in which case you wouldn't have much trust existing in that particular regard. And I should also mention that there's no hard and fast rule. You might find that an organization that has an ops team and a software development team will still implement hard multi-tenancy. In fact, the same organization that has different software applications that are deployed to a cluster will probably be applying hard multi-tenancy, because they don't want these workloads to be able to speak to each other at all, because they are in two completely different contexts, and they want them to essentially run in their own lanes. Okay, so you heard me mention earlier that this boils down basically to resource sharing and security, and those are basically your umbrellas at large for the different steps or techniques that you'd be taking to achieve your resource sharing and your security. And those 5 big green blocks that you see over there on the right are the techniques that you'd be taking. We're going to look at making use of cluster personas for our multi-tenancy, and then we're going to look at Namespaces. We're going to show how RBAC can help, and then we're going to take a look at network policies. And lastly will be resource quotas. And if you look at the diagram on the left there, you'll see that there is a Rancher logo, and you might be wondering, hey, at this point, we haven't heard anything about Rancher, so why is that sitting over there? Okay, so just going back to, and I really want you to keep thinking about doing this at scale. In the context of a single cluster, or maybe even 2, you might find that, well, I don't know if this will actually fit into my particular scenario, but we're looking at doing things at large scale. And what starts to happen is you're going to be managing this kind of multi-tenancy across multiple Kubernetes clusters, and those same, those complexities are essentially amplified. Your issues, or potential issues rather, can become, exponential if you don't manage things in the right way. And making use of Rancher is really going to help, because again, just like last week, we have this single pane of glass that gives us visibility of doing everything the right way and centralizing what we can centralize to help manage the different tenants across the different clusters. And it optimizes a lot of things. And so I'll be making use of Rancher for application of the different solutions that we'll be looking at. But also, I'll delve into actually showing you some of the manifest files so that you can actually get a real hands-on feel. Bear in mind, you can do a lot of these steps using the GUI and Rancher, but just following in a declarative approach, you would likely have a lot of these resources stored in a GitHub repository, making it easy to apply them. That's something you'll also see me demonstrate. And so I want to actually make sure that we have a look at that as well. And I am quickly going to actually pause here and have a look at some of the questions that have come through and just answer 1 or 2 of those so that we don't have too many for the end. And the question that I'm seeing over here is, can you host Rancher on EKS or AKS? I keep getting an error in AWS using this documentation. Okay, great question. Absolutely, you can host Rancher on EKS or AKS, essentially any Kubernetes cluster. In fact, with what I'll be demonstrating, Rancher is currently running on an EKS cluster. We had a challenge that went out last week. And this was part of the challenge, to actually get Rancher running on an EKS cluster. I'm not sure if you're a part of the community. If you are, then please reach out to myself or anyone else in the team, or have a look at that challenge and leave a comment there. We're more than happy to help with resolving those issues. If you're not a part of the community, please do join it. It's a lot easier to actually help you address these kinds of issues. But in short, absolutely, it's possible. I'm currently doing it. I'm not going to open that documentation link that you've shared just because of time at the moment, but we can chat about it further. And I'd be happy to share resources, happy to share a detailed walkthrough of how to accomplish that. And we will start off with cluster personas. Okay. And this is a good starting point. Put yourself in the shoes of an administrator who is essentially running the ship, quote unquote, and you have, on this ship, you've got your different teams that are going to be accessing this Kubernetes cluster. And a good starting point is not to just say, all right, everyone, please make sure you share the resources and make sure to respect everyone's space. That's going to be pretty difficult. You want to start off by identifying who's who and what their roles are. And that's essentially what you're going to be doing with cluster personas. Identify who would qualify as the cluster administrator. In this case, it will probably be you. So you will have full access to the cluster, and that is what I'll be showing. I'll be logged in as an administrator on Rancher, and typically you won't need to keep accessing the Rancher server as the administrator. Instead, what you're essentially doing is creating the playing field for other people to function in their respective roles as they should. And so what you'll then do is identify the different tenants and who the administrators are in those respective tenants, and taking it from there. You would then essentially enable those tenant administrators, who will then in turn identify who their tenant users are or tenant viewers are. And so what we're gonna do now is I'm gonna head over to Rancher, and I'm going to create two different tenant administrators. I will create them as standard users in Rancher, and these will be, I'll call them essentially the leads of two applications that will be deployed to the same Kubernetes cluster. All right, so I am in Rancher right now. You'll notice that there are two clusters at the moment. Local is for the Rancher server. This is currently deployed on an EKS cluster. And then you'll see Alpha, and that is a separate EKS cluster that I am currently managing. And so what I want to do now, though, is I'm going to have two different tenants or two different teams that are going to be deploying applications to the same Kubernetes cluster. So I'm heading over to users and authentication, where I'm going to create my tenants. And I went with Star Wars last week, so I'm going to share a bit of love for the Star Trek fans out there. I'm going to go with James Kirk this time around. James Kirk is going to be leading an e-commerce team. I'm just going to set a password over here. It'd be great if we had some elevator music to play while I'm filling in the boring stuff like a password. And so what I want you to see over here is I'm setting James Kirk as a standard user. So James Kirk primarily is going to be responsible for a project on a cluster. I'll get to the details of that and all of the resources that get created within that particular project. All right, now this as well, I should just mention, is basically how you would be managing or centralizing your authentication to the downstream clusters. Always good to remember that Kubernetes does not have an internal system for user authentication or user accounts. Rather, that is externalized, and it only has a role-based system for securing the operations on the API server. So this is also a great use case to see how centralizing that in Rancher makes things a lot easier. So I have given James Kirk some of the keys to the kingdom, and I'm going to create that. And as you can see, so that's been created. Next, what I'm going to do is I am going to create another lead for a team, and in the spirit of showing, Star Trek fans that, I do respect them, I'm going to give Spock leadership responsibilities over the other team. Does anyone know if Spock has like a last name or a middle name? Is this his first name? It's just one of the things I was thinking about earlier when I thought about who was going to be, the other leader of the team. Is like, what's Spock's last name? Just a trivial thought. Sorry about that. All right, so Spock is also going to be a standard user. I'm going to go ahead and create Spock over there. Awesome. Okay, so the next thing I want to do is I'm going to go over to my cluster, which is called Alpha. And I'm going to click on projects and namespaces. But before I go any further, let's talk about that. And so I'm going to head back to my slide deck. And now we're going to talk about namespaces. So this one might even have come off as a no-brainer to some of you as you were thinking about, how do you achieve isolation on a cluster? Namespaces is probably a good way. And you're right. Namespaces are essentially a way of achieving virtual clusters on the same Kubernetes cluster. And that allows division of access control. It allows you to set resource quotas. So whatever workload is running within a specific namespace, you can set limits on that. And this is a really cool way of actually, achieving what we're going for over here. I know last week I spoke about how you could have different environments spread across the different namespaces, such as dev for a namespace, staging for a namespace. But you could also have an application running within a particular namespace, and that could still represent a specific environment. But I think you're getting the idea of what I'm going for over here. And those are a native Kubernetes object. But you'll see that I'm also mentioning project, and that might get your head scratching a little if you've never heard of it. For those of you that are very well versed with Rancher or familiar with it, then you will know that this is a custom Rancher object, and it essentially allows you to group your namespaces. And this comes in handy because you can essentially assign resources at a project level, and it makes it a lot easier as well to manage multiple namespaces. And if you think about it, you could basically apply this even when it comes to your different tenants. So you would have, let's say, in our case, James Kirk's team will have a namespace, but above and beyond that, they have an application that they're responsible for. And you could tie that to the project, and they could be multiple namespaces under that specific project. So they could be named, so they would have, for example, the different environments under that, and Spock likewise will have a project, and that project will have respective namespaces under it. So let's take a look at that now and how to do that in Rancher. And so just so that we can spend a bit more time on the things that I think would be a little more interesting for you, I've already gone ahead and created the two different projects. You can see over here, Project E-commerce and Project Express Node.js, but I'm going to go through the process of just creating one so you know exactly how it works and how easy it is to do it. And so I'm just going to call this project example. So you'd set the example, and then in line with what we're actually going for, you could actually set your resource quotas at a project level. And so that would be above the level of your namespaces. Now, I'll be demonstrating a little bit later how to do this using namespaces, but just so that you're aware, you can actually set this at a project level as well. And so that's just to show you resource quotas, and we'll be talking about that a little bit later. And you can do the same for the containers that will be running within this particular project. And all of this is super important because this is where you essentially set the limits or the walls on that Pac-Man grid so that containers are tethered as opposed to them having a free reign when it comes to utilization of CPU and memory. In addition to that, this is where you would actually manage who has access to what project. So if you think back to the cluster personas and who we created, I'm going to click here and add, and you have different types of permissions when it comes to a project. And if you can see over here, we've got owner, and the owner has full control of the project and all the resources inside of it. A member, on the other hand, can manage resources inside of the project. So that would specifically be the namespaces, but not modifying the project itself. And to add a member, you would simply enter one here. So I'm just going to enter Spock, and you can see that is what you would be doing. You'd then just select Spock, for example. There we go. Oh, this is a little bit of trouble with this even last week. Very funny. All right. Nonetheless, I'm going to head back to projects and namespaces. I want to show you over here. I'm going to show you the e-commerce project. Let me go a step back. I'm going to show you the configuration. Right, so I actually haven't added any members to this as yet. So this will be great for demonstrative purposes. So e-commerce, as I mentioned earlier, is basically, this is for James Kirk. So let's hope, this is very weird. The selection is giving me some trouble. This is actually really important. Like I said earlier, it'd be great for that elevator music. Awesome, there we go. Okay, so I'm adding James Kirk as a member. And so this is basically what James Kirk is responsible for. Alternatively, you can set James Kirk as an owner, and James Kirk will essentially be responsible for who he then in turn adds to that particular project, which is the norm of what it would be going, because James Kirk is working in the context of a team. So I'm going to save that, and I'm going to head over to Express Node.js, and this is for a Node.js application, and this is another tenant in the same alpha cluster. I'm going to edit the configuration, and I am going to add Spock to this. Let's see. Awesome. Okay. First time. Like it. Save that. Great. So now if I were to log in as James Kirk, for example, James Kirk will have access to the alpha cluster, but when it comes to projects and namespaces, James Kirk will only have visibility of e-commerce. So I'm going to quickly log out, log back in as James Kirk. Okay. Namespaces. Okay, so you can see over here under namespaces, James Kirk only has access to e-commerce. The reason we can't see projects is because I added James Kirk as a project member as opposed to an owner. If I had added James Kirk as an owner, then we would have visibility of the project and be able to modify those configurations. So at this point, James Kirk only has visibility of this namespace that he is in charge of running and deploying resources to. And it would work the exact same way with Spock, except it would be the Express Node.js namespace. So we've created our projects, we've got our namespaces running, and we've added the respective tenant administrators or leaders to them. So let's see what's next on our list of making sure that we're getting our cluster ready and right for multi-tenancy. Next up is RBAC. And you heard me mention earlier that this is the way in which you essentially secure the operations on the API server of your Kubernetes cluster. You've probably heard it said, that Kubernetes is API centric. All the operations go through the API server, all your CRUD-based functions. And so how you control who is allowed to do what is with role-based access control. And you have 4 API objects. You've got the role, you've got the cluster role, you've got the role binding, and the cluster role binding. And the role, as you can see over there, is used to determine which operations can be carried out on which resources in a specific namespace. So you might already be thinking, all right, great. So this fits right back into the thread that we're going with. We've created our cluster personas, and I'm just going to use James Kirk as an example. James Kirk has been created. James Kirk has been put in charge of the e-commerce namespace. And now we want to make sure that whatever resources get deployed to the e-commerce namespace, that we make sure that they're able to carry out whatever functions they can within that specific virtual cluster or that context. Apart from the role, you've got the cluster role, and as the name implies, this allows you to carry out operations on resources on the scope of the entire cluster and not just a specific namespace. So we won't need that for this particular example. In fact, I would even just say that whenever you're making use of a cluster role or a cluster role binding, you have to be very careful. Make sure you understand the implications of it. You're essentially giving permissions to make changes at a cluster level. And when you're doing things at scale and on a large scope, your implications will be across the board. And so just make sure you have a good understanding of what resources are being created and why they actually have those permissions to do those things. Role binding and cluster role binding. So a role binding is essentially the way in which you attach a specific role, because the role is what has the permissions defined. And then you then attach that role to specific users or service accounts. And so cluster role binding works the exact same way for a cluster role. It's in the name as well. It's binding specific users or service accounts to a particular role. And so I'm going to turn over to the editor now and actually want to show you an example with the particular applications that we'll be creating. So I've got my editor open over here, and let me just expand this a little bit further. And I want you to see that we've got 2 applications in the 2 different folders. We've got mock e-commerce backend, which is the e-commerce application that James Kirk is responsible before. We've got the mock Express backend, which is essentially what Spock's team is responsible for. And so under this, in raw manifests, we've got the different Kubernetes resources or objects that will be created. But right now we're focusing on RBAC. And so I'm going to open that, but I'm also going to open service account. And so I'm going to start off with service account because, how did that happen? And so the service account is what you want your pods to essentially be using. This is how you set their identity. They're going to be making use of the service account in order for them to carry out any functions. And so as you can see over here, the service account, I'm giving a specific name, Express Node.js, and then service account. And it's going to be operating within the Express Node.js namespace, which is the namespace that Spock is responsible for. And if I come over here to RBAC, I'm going to collapse that just so we have as much visibility as possible. And we can see the role that is being created. You can see that under kind. And then the rules, this is where you basically define the different permissions for the specific role. And as you can see over here, this is what I'm giving the Express Node.js role to do. It's going to be able to, this actually gives it a lot of permissions. When you leave that blank, you're essentially indicating the core API group, as I've put a comment over there, and apps, which would be like for deployments. And then resources is where you would define the different types of resources for the role, and the verbs. And when you think of verbs, you're thinking essentially about your HTTP verbs. And so this is an example of that. And then role binding, in this case, like I mentioned earlier, this is what you use to actually attach a specific role, in this case to a service account. And as you can see over there, the subjects, I only have one subject, which is the Express Node.js service account, and the role reference I'm adding over here for that specific role. Great. So this is what is going to be created. And bear in mind, like I said earlier, you can do all of this through the GUI, but it's very good to have this as well stored in a repository. And it's a lot easier because you've got your declarative, your declarations rather, in the form of manifest files, and they can be created at the same time. Right. Awesome. So I'm now going to head back to my slide deck. And so what we'll be looking at next is network policies. All right. And so just going to do a quick review of what we've covered so far. We've covered cluster personas, and we created James Kirk, and we created Spock, and then we created namespaces and we also looked at projects. And so that's just sort of organizing things within the cluster so that we know the rooms or the realms that these particular teams can operate in. And then beyond that, we want to make sure that we define what they can actually do when it comes to interacting with the API server in the Kubernetes cluster. And that's also a good way of setting your permissions. And with pods, they identify with the service accounts. And so I've shown you how to work with that. And so the next thing is to cover network policies. All right, so network policies, for starters, as I say over there, by default, all pods in a cluster can speak to each other, and network policies can be used to secure and restrict the ingress and egress traffic to and from pods. And this comes in handy when it comes to that security and that privacy, especially from a hard multi-tenancy perspective. And so you have different fields that you would be specifying to essentially implement your network policies. There are different approaches that you can take. And so the one that I'll be demonstrating is just by setting the ingress rules, which will essentially be setting the traffic that a single pod in a specific namespace allows to come in. And I've purposefully not set any ingress rules because that's going to be part of the challenge that is going to be coming out tomorrow. So I hope you're looking forward to that. But I'm going to head over to my editor now, and I'm going to show you an example of a network policy. I'm going to collapse that, and you can see over here. So this is the network policy for the Express Node.js application. So basically, Spock has told his team, hey, everyone, we need to make sure that the traffic that goes on across the pods within our namespace is restricted to this particular namespace, the Express Node.js one. And the way of accomplishing that under the spec, as you can see over here, you would select specific pods, and we're doing that based on the label that is attached to those Express or Node.js pods. And the one that I have here is role Express API. If it will help, just for a bit of context, I'm going to open the deployment manifest file, and you can see that role Express API is one of the labels that I've attached to my pods that are being controlled by this deployment. And so now over here, I'm defining an ingress rule. And bear in mind, you can define ingress and egress, and that is a very good practice, but I'm saving the egress for you when you work on the challenge. But this will still work. And so for ingress, you can see over there, I'm specifying a from rule in this array, and I'm specifying both the namespace selector and a pod selector. And so what this will do is it's basically saying that it will only allow traffic coming from any pods that have a particular label with this key value pair, role Express API, and also for a specific in the namespace that has the label tier Express backend. So that means only traffic from within this namespace, and it has to be this particular pod. Now you could make a little looser than this. You could remove the pod if you want it to be any pods within a particular namespace. This is narrowing things down in a very specific way.
All right, so I'm back in Rancher, and what I've actually done is I'm accessing one of the pods that are running in alpha inside of the e-commerce namespace. As you can see over here on the left, this is one of the GraphQL containers, and I've shelled into it. And what I want to actually do is to test accessing a pod inside of the other namespace, which is Express Node.js. And remember, what we're essentially trying to achieve is to prevent this kind of accessibility across different namespaces. But at this point, I haven't yet implemented the network policies. So I'm going to test that out. To do that, I'm going to be accessing the Express service for the Express test Node.js application, and it is in the namespace called Express Node.js. And I have to specify the port as well, which is port 8080, and I know that there's an endpoint on that particular application called test. And as you can see over there, that it was actually successful. So if I run a cat command on test, that is the response that I would expect from the Express Node.js application, specifically the /test endpoint. So we're getting the correct response, but we don't want these pods to be able to speak to each other. And so if I was to run the exact same thing inside of the Express Node.js application, right, and now I am inside of the Express Node.js namespace, and I'm going to make a request to one of the microservices running inside of the e-commerce namespace. So I'm going to run the same wget command on orders service, and I'm going to specify the namespace that it's running in because it's a different one, and the port that it's listening for traffic on. And you can see even this request was successful. So we've tested traffic from the e-commerce namespace to send that sends a request through to the Express Node.js namespace, and that worked. And the same thing has worked out when I'm making a request from the Express Node.js namespace to the e-commerce namespace. So if I just run a cat command on orders, you'll see over there I get a response, the expected response. This is a list of orders or an array of orders. And so we don't want this. So what I'm going to do is I am going to collapse this, and I will head over to continuous delivery. And so I've already got the network policies inside of the respective repositories, but I had deleted them. So all I have to do at this point is just force an update so that those network policies can be redeployed. I just have to wait a couple of seconds for this. Great, and it looks like it's active for e-commerce. As you can see over there, the network policy has now been applied. It's in a ready state. I'm gonna go a step back, and the same thing with the Express. The network policy has also been applied. So what I can do now, I'm going to head over to Alpha, and then I'm going to go to the workload. And And if I click on the pods, and I'm going to select any one of them from the e-commerce namespace, I'll just use the same GraphQL application. And so I've shelled into the container, and I'm going to run the command wget orders service. I'm going to start by making sure that I can access pods inside of this namespace. Okay, great. So I'm getting the right kind of response. And then I just need to make sure that there is no test that already exists. So then I'm going to run the wget command. But now I'm going to try running a query against the Express service application. Specify the correct port. And as you can see over there, it's attempting to connect to it, but it's actually failing because there is a restriction on the side of the Express application, specifically the namespace that it's in, because the network policy is preventing any ingress traffic from outside of that particular virtual cluster. And so this is exactly what we want. And we want to make sure that the same thing is being carried out on the side of Express Node.js. So I can just go ahead and select any one of these. And I will run the exact same type of query. I'll just go with products this time around. Products service, e-commerce. And this should be running on port 3004. Run products. And as you can see, again, this connection is actually failing to go through because the ingress network protocol or policy that is in place in the e-commerce namespace is preventing ingress traffic from outside of that particular namespace. So this is giving us the result we want. We've set up the correct isolation for these two namespaces.
So we're going to cover the last one, which is resource quotas. And resource quotas you would have already seen earlier when I was showing you the process of creating a project and a namespace. And when you're creating resources, or rather when you're creating projects or namespaces, you could set these right away at that level. But it's also really good practice if you're just going to set them at a namespace level or create a specific resource quota Kubernetes object itself. And this is a good way of basically setting those limits on how much CPU, how much storage, how much memory that the resources can be consumed, how much resources can be consumed by the pods within a given namespace. And so I'll show you the setting of namespace limits. You already saw it earlier. And then pod limits, this is also a really good one because in most cases, you'll find that a single or a certain type of pod will have certain replicas to increase your traffic, or rather to be better equipped to handle increasing traffic. And that's a good thing. But in the context of running multiple applications with multiple pods that each have a certain count of replicas, you want to make sure, again, just going back to that resource sharing and thinking about those respective rooms, you would essentially be setting limits for the e-commerce team, which is spearheaded by James Kirk, and letting James Kirk know, hey, for every specific type of pod that you're going to be running, you have a set limit of running 2 replicas. And that's just an example. And in turn, you'd let Spock's team know the exact same thing. You're going to be running a maximum of 2 pod Spock or rather 2 replicas for the specific pods that you're going to be running in your workloads. And this is a really good way of managing that. Optimization is a journey. That's something I do like to say quite often, because as you are continuously working on this, you'll be better. You'll have more visibility and understanding of just how much your containers require in order for them to run optimally. And in that case, you'd be able to set better limits and thresholds. But the important thing is to actually have those thresholds in place to avoid any performance issues. This is one thing that the demo gods cannot prevent me from. It is the source code that I have locally. And so just over there to show you an example of the resource limits for memory and CPU. And look, again, you might find that you're feeling a little uneasy because your team kind of sets things arbitrarily to begin with. But this is where metrics comes in, is very important. And you can modify this as needs, or rather as the journey goes along and you start to identify better and better what the particular needs for your workload is. All right, and that being said, in this case, I am now going to call it, and we're going to move over to Q&A. I see there are a couple of additional questions, which is great. I'm going to stop sharing, and I hope I'll be able to see Tim's face and to hear him. It definitely makes the experience a little better. Otherwise, I'll just proceed to continue with the questions. Can you say something about how different Kubernetes CNI providers can help with security and multi-tenancy? Which one you prefer and why? Fantastic question. I think this is Natasha. Great. And essentially, you would be making use of CNI plugins to actually make use of, multi-tenancy, or rather making use of network policies for multi-tenancy. And so in my case, I installed Calico to run alongside the AWS VPC CNI. And so they're different CNI providers, but they're all going to give you what you're ultimately trying to achieve, which in this case is creating your network policy. So if you're asking me which one I prefer, I would say Calico, but if I'm being honest, it's primarily just because that is the one I've used the most. I haven't done it with other CNI providers when it comes specifically to creating the network policies, but it is important to install the CNI plugin because the Kubernetes API server needs to understand that. And so if you go without a CNI that can actually handle the request to create a network policy, it will appear as if that it has actually created it. And you could be under the impression that your workloads have the sufficient isolation or security that you want, but those policies are not actually in place. And the main reason I really wanted that last part to work, but I'm having some network issues, is because I wanted to demonstrate to you. I'm sorry. I think it's Walid who's distracting me with this comment. This is like Calico of a lovely mascot. I agree. And so I wanted to show you how you can actually carry out good tests to see that, is traffic actually going to pods that it should be going to, and vice versa? Are there pods receiving traffic that they shouldn't be receiving? So I hope that helps. Right, and I see Walid over here. I hope I'm pronouncing your name right, by the way. The challenge is onboarding users. If you can talk about how to effectively onboard users. Wow, that's a great question. And from the onset, I have to say, I was, when I was working in a setup where we were applying multi-tenancy, I was part of a DevOps team, and we were working with software developers and we were working with testers. But I think our use case could even probably be, that could qualify as very small compared to what, much larger organizations could be dealing with. So this onboarding users could be quite subjective. But what I would say is that I hope that what I actually demonstrated in the presentation helped. It starts with the cluster personas. It's easy in these kinds of situations to want to get people up and running, especially when you think about what, the software development lifecycle is actually like on the ground. People want to hit the ground up and running and get started and deploying things, but you have to start from that point of identifying who's who when it comes to our different tenants, what are their respective roles, and taking it from there. That is the starting point when it comes to onboarding users. Identify who your tenant administrators are. Have an effective way of actually managing these tenant administrators and giving them the right kind of permissions, just like I demonstrated with Rancher, giving them the right kind of permissions for them to in turn then essentially have the freedom to run with things. Because if you're going to have your one Rancher administrator, for example, trying to take care of all of this, that's not a good federated approach or a good way of managing things. You essentially want to empower the people who lead these teams in a secure way with a platform like Rancher to then be in a position where they would essentially have a virtual cluster. So it's basically like they have their own Kubernetes cluster to then run with things. But it all starts with the cluster personas. I hope that helps answer your question, Walid. If not, if there's something more specific that you want me to touch on, please do shoot the question right there again, or you can add another question. Any comments on the recent EKS Anywhere SUSE Rancher being a big partner? One, it's exciting. That is fantastic because now you can basically run EKS in an on-prem context. And with regards to Rancher being a big partner. Well, with SUSE Rancher, you could already, even prior to that, prior to EKS Anywhere, you could use Rancher to manage on-prem clusters as well as clusters in the cloud. So this doesn't change anything from a SUSE Rancher perspective. If anything, it's just more of a reason to make use of a platform like it, because now you might find that teams or companies that have been making use of EKS specifically in the cloud context, because that's what they were restricted to, but are now starting to think, oh, we can also leverage on-prem now and have EKS in the cloud and on-prem. And that's great, because you've got that level of consistency in that you're using it's EKS and it's still Kubernetes. However, managing multiple clusters, this kind of goes back to last week, managing multiple clusters still adds layers of complexity. It's all the more reason to have a single pane for visibility. And your networking architecture, for one, is something that's going to look a little bit different, because you're not going to be dealing with the same kind of networking that you'd have in your AWS VPC. Now you have that in the context of the cloud. So you might have some tweaks that might need to take place as it pertains to your workloads on your EKS clusters. And again, just taking the step back, you want to have consistency and you want to have alignment across your clusters. So as it pertains to SUSE or Rancher, all the more reason to make use of something like that. So I hope that helps, Walid. Again, if I'm not answering your question, just shoot it there. Can we achieve hybridity between multiple Kubernetes clusters? When needed, the app instance can be scaled to a different cluster. Well, if I understand your question correctly over here, this is somewhat like cloud bursting, so to say. I think I get what you're talking about. And so I'm going to, because you're using the term hybridity, that should be on a t-shirt. I'm thinking about also like a cloud hybrid model where you'd have like, for example, on-prem and public cloud. And so now in the context of Kubernetes clusters. And so I think what you're actually talking about is something like having somewhat workload portability and being able to have your application scale to different clusters. That would probably come down a lot more to your proxying and your load balancing layer, as opposed to the application itself. Because if you think about it, you'd have a workload running, let's say on-prem, and a workload running in the cloud. And what you basically want to be doing, based on scaling and routing rules that you would define at the entry level, you can then basically determine where you want that traffic to be redirected based on certain thresholds being hit or something of the case. So I hope that answers your question. I'm not seeing, that's by Durga. Again, Durga, if that doesn't answer your question, please let me know, but I hope that definitely helps. So again, I think you're kind of alluding to workload portability, which Kubernetes helps with because it's infrastructure agnostic. You're likely going to be looking at maybe running workloads in the cloud and on-prem if you want to sort of maybe even have some kind of trigger that will hyperscale your cluster in the cloud in the case that the on-prem cluster starts, quote unquote, suffering from a high level of traffic. But bear in mind, there's also going to be a lot of hard work at the entry level when it comes down to load balancing and traffic. Just before I close, I will say again, the cloud native journey, I said this at the end of the last session, is a difficult one. It is very vast. If you've been a part of it for some time, you'd agree with me. If you're new to it, you probably already feel overwhelmed. But the journey goes a lot better and easier when you're doing it in community with other practitioners. I'm a practitioner. Tim is a practitioner. A lot of us in this space are all working hard to figure out not just how to do things in a way that works, but the best way of doing things. And we have a lot of content that helps in that regard, a lot of on-demand resources that exist in the community, and it is free. So all you have to do is sign up if you haven't already done so, or maybe you signed up a while ago but haven't really been making use of it. And apart from the on-demand resources, you can reach out to myself, Tim, our other teammates, and we would be happy to help on the journey. So great. Before you sign out, I just want you to say again, let us know how you found the session, whether it was helpful or not. And if you also want to give more detailed feedback, that's also something that you can do. You can direct message me in the SUSE and Rancher community. But from my end, thank you so much for tuning in. like I said, I was excited about this one in particular because it's something I've dealt with. And so I can very much resonate if there are any people who are in a similar context. Thank you for tuning in. Have a great rest of the week. Please be on the lookout for the challenge that is going to go out tomorrow. I'd love to see more participation in that regard. And we have another great session that's going to be coming up next week. And you don't have to wait that long for us to chat again. We have an office hours that is coming up this Thursday. So bring it on with Luke is what we're calling it. And bring your tough questions. And I will try not to spend the whole time scratching my head and saying, I don't know, so cool. Thanks again, everyone. Goodbye.